Okay, cool. Here we go. Hi, everyone. We're doing a combined talk here, James and I. I'm going to be talking about the kind of history of Elixir and rules engines and how their pasts are shared and connected, as well as like what is a rules engine, why might you want to use one, and then how to use one. And unfortunately, you'll leave this talk sad that there is no rules engine in Elixir. And then we can have a short break. And then hopefully, James will make you happy again by introducing a rules engine in Elixir. But yeah, so I'm going to have probably less Elixir in my talk than you might like, and less than I would like as well. So let's jump right into it. Real quick about me and my background with respect to rules engines. I'm VP of engineering at Seven Shifts. So we do like scheduling and labor management for restaurants. I'm former CTO of Precision Nutrition, and we have lots of rules engine action there. My native tongue is Ruby, so there'll be some Ruby in this. But I am a big time Elixir and Erlang fan. And Justin and I founded T.Erl in 2008, the original Toronto Erlang user group. But in hindsight, I've been using rules engines in one form or another since at least 2008, where kind of first production use of Prolog for a scheduling app for doing constraint solving on time and so on. But I should warn you that I'm not an academic. So this is like how you might want to use a rules engine and what it's useful for, but I really don't know how they work inside. I think James knows how they work inside. So hopefully he can answer any questions about that. So let's jump into this. Why are we here at an Elixir Night talking about rules engines? Just some history to start. So Jose Valim, creator of Elixir, said that his aim was to keep Erlang's same abstractions process message model, but improve developer productivity. So really, Elixir was built on Erlang, and Joe Armstrong, one of the creators of Erlang, said it was never our intention to develop a new programming language. Erlang emerged as a side effect of an attempt to find an elegant way to program a telephone exchange. So let's keep going with the history here. So where does Erlang syntax come from? So this is like Erlang's academic and historical questions. It comes mostly from Prolog. Erlang started life as a modified Prolog. I'm going to go real deep, guys. Okay, here is the original paper that introduced Erlang in 1992. It's called Use of Prolog for Developing a New Programming Language. And in it, Joe says that had it not been for Prolog, it is doubtful whether a language such as Erlang would have emerged, because Prolog provided the kind of interactive environment which could accommodate the rapid changes in direction which occurred during the development process. And I think when he said interactive environment, this probably wasn't what he was talking about, but this is what Prolog was originally written for. This is the interactive environment. So, I mean, obviously what he means is the kind of the Prolog, the behavior of the system itself. So more history, don't worry, we'll get to something pragmatic at some point. But so Prolog is short for programming logic. So it's a logic programming language that was first introduced in 1972. It's like old school expert system, AI, like the old definition of AI. And it's just a declarative rules-based language, which I'm going to dig into some more details here. But basically, Prolog is a rules engine. I got to be a little fast and loose around like a modern rules engine versus Prolog. Prolog is a crappy old rules engine. Let's put it that way. And in the years since, there's been lots of rules engines that have kind of built upon it and added to it. So like the main ones you might have heard of today are like Drools. Nools is a JavaScript version. MuleSoft, the platform actually either integrates with Drools or has some kind of its own rules engine. And there's I could have thrown a million logos on here, but there's a bunch of rules engines out there that are kind of like arguably the grandchildren of Prolog. But actually one of the ones that I'm most familiar with is Wongy Engine. Wongy Engine, which is a Ruby implementation of a rules engine that Precision Nutrition uses heavily internally. And the way it uses it is to be able to process events and to basically isolate all of the business logic related to courses away from the code, keep all the nasty business logic away and keep it tamed. So where an event like activity assigned or message sent would get processed by the rules engine, and then a bunch of like simple, easy to understand rules would fire and determine if something needs to happen. I'm going to go way deeper though. Okay, so this is kind of what a rules engine looks like inside, but I'd like you to not think about that yet. So let's just imagine it's a glowing ball of light, you know, like the Mind Stone or something. And effectively it takes facts and rules and then magically somehow produces like actions or decisions. So before I go into like how it works inside or how to use it, I'm going to try and explain why you might want to use one, because I don't think anyone will bear with me for the madness if you don't see the value, the motivation behind it. So the main advantages of a rules engine over, you know, traditional programming are separation of logic and data. It's declarative, it's explainable, it's understandable, and it centralizes your logic. I'm going to dig into each real quick. But it separates your logic and data. So you're probably pretty familiar with like normal object-oriented languages, which like object-oriented is the exact opposite of separating your logic and data. It's like, let's smush our logic and data together. So yeah, Ruby, Python, C++, JavaScript, PHP. But then on the like separated side or the more declarative side, you're probably pretty familiar with CSS, SQL, Prolog maybe, regular expressions, XSLT. So they all have this really extreme separation of data, logic, and then in some cases actions. Obviously like regular expressions can't really do actions, but if you're familiar with regular expressions, this is like hopefully comfortable that, yeah, okay, the logic is the regular expression, and then the facts are really like the text corpus that you're matching against, and then the results are like the output from the rules engine. Okay, it's also declarative, so basically you say what to do, not how to do it. So again, like to compare an imperative query in Elixir against a SQL query, you know, in the case of saying, okay, give me all my customers, iterate over them, and return any of the ones where the country is Canada, versus give me the customers where the name is Canada, I don't care how you get it. Another thing is it's explainable. So like to contrast it with machine learning, a rules engine, you can always take any answer or action and go backwards to why it did what it did. And whereas obviously with machine learning, that's not the case. Once you've created the model, then effectively you lose the ability to explain why something occurred. And another thing is it's deterministic, which means that for the same inputs, like the same facts, the same thing will always happen. So it's easier to debug. It's, you know, in contrast to something probabilistic like a machine learning model, where basically the exact same data going in might produce a different result the next time you run it. The other thing that is awesome about rules engines is they allow you to centralize all of your logic and concentrate them away from, I don't know, nasty bits elsewhere. So this is a very rough, like these are some of the DDD domains at 7shifts. And effectively, so you've got messaging, scheduling, billing, and what have you, but where do you put things that span all of the domains? What's the place for these things to live? Obviously, like DDD has some answers about that. They're not awesome answers. In contrast, the rules engine is, I think, the awesome answer here. So like theoretically, what one might do if you have a whole bunch of different domains with a like CQRS model where you have commands that each domain accepts and each one is emitting events. The role of the rules engine is effectively as an event processor, where you're pulling logic from all the domains into a single place. You're pulling the data or facts from all of the different domains into a single place. You're making decisions on them, but then you're issuing commands back to the individual domains. Again, like I'm not expecting anyone to walk away from this and like, oh, okay, I'm ready to start using a rules engine. This is like, maybe you should use this 1970s tech. So yeah, you know. Another way that they can be used is effectively embedding them within a service. Like it doesn't have to be this magic thing that sits between everything and coordinates it. You can use a rules engine inside of a service where the conditions are necessary. And I'm going to go over some of like the conditions that might lead you to think, damn, I need a rules engine. But a dynamic pricing service is a pretty classic example because it has really complex logic and it's constantly changing. And so by kind of isolating all of the logic, even within a single service or domain, it lets you just quickly swap out stuff without having to change the rest of it. So kind of classic cases to use a rules engine, there's definitely more, but like the main ones where people generally reach for them are when you have complex logic, there's no known solution, you have volatile requirements, partial data, or if you need to empower non-technical domain experts. And I would say that any one of these being true is sufficient, but if more than one is true, well then damn, you need a rules engine. So examples of complex logic are fraud detection and credit scoring, but surprisingly enough, like Slack notifications, this is, I don't know if anyone's seen this before, but this is the flowchart for deciding whether or not to send a notification to a given device. So for every user, users have multiple devices, you're on multiple devices at once. And as far as I understand, every time anyone posts a message anywhere in Slack, some variation of this like gets evaluated. This is the classic example of like they should have used a rules engine. As far as I know, they don't. And so this is probably like hundreds of lines of if statements or who knows what. Volatile requirements, dynamic pricing, regional tax rules, integrations. Integrations between different systems. And this is where developing Erlang came in. So this is why Joe and the gang used a rules engine to develop Erlang, because they didn't know what they wanted. It didn't have a known solution. And so they were able to quickly iterate on it and keep changing the definition of the language without having to write an interpreter, compiler, and whatever else might have been required otherwise. Partial data, which is, imagine somebody comes to your site and you know nothing about them at first. And then as you learn more and more about them, it starts giving you hints about them that you can use to personalize the app or site, and you build upon it. Every step of the way, you're adding new facts about them. And so this is also like really, really nice. And you'll find that most of the commercial rules engines out there right now really like focus on this as the core driver. If you're talking like a big enterprisey rules engine, they're going to be like, yeah, this is about site or app personalization. And to empower a non-technical domain expert, this is Drools, which is like the big 900-pound gorilla in the rules engine space. It's all written in Java. It's like part of JBoss, but it's filled with GUI tools that let non-technical users write rules and test them and check what the results would be and check the explanation for why something occurred. So that's really set up for you to kind of do all the work of exposing a bunch of actions, pumping in a bunch of data, and then letting a non-technical domain expert mess around with some tooling to define what they want. Okay. So now that hopefully you're convinced that rules engines are worth at least learning a little bit about how they work, let's talk about how they actually work inside. So effectively, your facts and your rules are kept entirely separate. You have to feed in facts, you feed in rules, and then the pattern matcher in between decides which rules fire. And it's kind of a many-to-many match, similar to a regular expression. So I'm going to focus first on facts. From here on out, please stop me 100% if I lose you, because it's going to get weird and I don't know how understandable this is. So look, you're used to having data, comes out of a database. What's the difference between a data and a fact? Well, all facts, at least in the context of like modern rules engines, are in the form of subject predicate value. Like burger is a food. Luke likes burger. You don't use plurals, So this is two facts. Burger is a food is one fact where the subject is burger, and then Luke likes burger is another fact, but it's referring to the subject. The value in one is referring to the subject in another. Hopefully that makes sense. But what does that look like in like real world usage? Here's some Elixir. Imagine I have a burger. It's a food named burger, and Luke is a person named Luke, and then burger is a food, and Luke likes burger. So this is basically the kind of thing that you have to do in order to get your data out of whatever form you have it in a database or what have you, and kind of feed the machine in the form it expects to receive like knowledge instead of data. So I'm going to use the Slack example because of the fact that they had that insane flowchart. So I think it's a classic example of like maybe they should be using one, right? So let's talk about like what would that crazy Slack thing look like in a rules engine? So, Elixir is a channel, and Elixir's availability is private. Luke's a user, James is a user. Luke is a member of Elixir, James is a member of Elixir. Message blah is a message in channel Elixir from James. So hopefully this is, makes sense from a, like, I'm moving fast because, I have a lot of slides, but the hopefully this makes sense that, you can take this kind of form and translate it into a series of tuples. And arguably this is why tuples are a thing in Elixir and Erlang, is because it all stems back to tuples as like the dominant way of expressing facts. So Elixir is a channel, Elixir's visibility is private. Does this make sense? I hope. Yeah. Not
Question about, the use of tuples, right? It's about positioning too, right? That's the reason, at least just generically, tuples are about positioning, right? The position of the value, if it's a key value, the position matters. In this case, as things are moving, right, you have your subject, predicate, and value, right? And so, obviously subject and value are, going back and forth, right? In your burger example, how would you, I'm just trying to wrap my tuple brain around the fact brain, the fact convention, right? So that's the.
Yeah. So, okay. So, like one thing about tuples is that they're like a constrained length, right? So, like if you
Yeah.
length of three, so it generally, at least like the rules engines that we were using at PN, without any fanciness, you don't get to have more than three. There are
Okay.
rules engines that can do more. It is totally okay to have something you're referencing in a value occur later in a subject and vice versa. The arguably this is more about convention because however you store the facts, you're going to need to write your rules with that structure in mind. So you could do something totally crazy. I don't even think there's anything stopping you from saying subject value predicate, but you'd better be consistent or else the person who writes the rules isn't going to understand what's going on.
Okay. So you just have to identify the convention ahead of time.
That's right.
Yeah.
That's right. I'm sure James could clarify this, like, but I don't believe there's anything magic about any one of the order. It's basically just that you need to be consistent, or nobody will understand what's going on. In fact, Prolog inverts the order, so it becomes a predicate subject value in Prolog, which I don't really dig. So I didn't even bother trying to teach that. Hopefully, yeah. Okay.
Um, I would like to understand in one of the slides you mentioned that developing Erlang was was that an example of rules engine like where you need it? I didn't quite understand that particular. But I think that's the core of the talk here, right? Like Erlang was
Yes.
designed around rules engine,
Yeah, I can jump back. Well, I'm not going to jump back to the slide, but let me
right?
explain. So, Connor called out that Erlang was 1986, and I think that makes sense. 1992 was the paper explaining how Erlang was made. But so the whole thing is that the way that they went about building Erlang was that they got a whole bunch of people together, like beta users or what have you, that were going to iterate on like what is the best way to program the telephone exchange. And they use the rules engine to effectively like define a DSL for. So the idea was that by defining, so rather than build an interpreter and effectively like go down the path of building a DSL and something to interpret the DSL and then execute on it, they decided to use Prolog as effectively like they made it so that the way you program the DSL is by defining facts, which themselves are, yeah, this is hard to explain. I honestly had like a whole nother talk that shows how Prolog syntax maps onto Erlang and Elixir syntax, and you can kind of see how it made its way there. But the gist was that the language itself was defined as a set of rules. And then when you're writing a specific Erlang program, you were effectively like, you were also writing a bunch of of rules, and they would issue a query each time a message came in. And so as a message, you know what though, this is I could spend the next half an hour explaining it, but the gist is that that they use the rules engine in order to like skip a bunch of steps and make it easy for them to quickly redefine the language, introduce new syntax. And obviously, I'm going to get to it later. It led to some problems later, which is obviously why it's not based on Prolog anymore.
Thank you.
Yeah, no worries. Okay, cool. So hopefully we've covered facts. I'm going to dig into rules now, and it's going to get harder. So rules are basically your condition, action. So you're like, when the following conditions all, like it's a chain of conditions, and when they all are satisfied by any set of facts, if a set of facts satisfies all the conditions, then effectively it triggers the action. I'm going to keep it's going to make sense eventually. So the conditions are kind of like a matcher followed by a template, where a template might be subject predicate value. So most matchers take like matcher, subject predicate value. So an example of a matcher is like, I'm going to go over all of them, but the like has, like, or doesn't have. So here's an example of like a real rule. When there are no burgers in the store, close the store. And so the condition here is when there are no burgers in the store, the action is close the store. There are no is the matcher. Burgers in the store. There you go. So there are no matcher. Burgers is a literal, so we don't mean like something. We mean specifically burgers. And store is a variable. And then when we say close the store, so close is the action, and then we're referencing the variable. And so in the same way that when you use a regular expression, you can refer to like matches from the regular expression in, say, a substitution. In this case, in the action, you can refer to the variables that were part of your templates. So you can see that like this means it's the same variable. So it will yeah, anyway, and hopefully you can see how this might have impacted the Elixir and Erlang syntax, because obviously this is like kind of leading up to the pattern matching syntax that we see in Elixir and Erlang. But you could also write, there is no food in the store, close the store. And effectively all that would mean is changing the literal burgers to the variable food, because anything could match food. So we're cool so far. It's, you know, I'm going to keep going, but so this is an example of like actual syntax. This is the Ruby syntax for the Wongy engine. So we'd say rule, no burgers in the store, close the store. That's just English to make it easier. And so we'd say like for all the facts we have, if it has store as a store and it doesn't have burger in the store, then close the store. Done. Right? It's, you know, I get that this is a bit of a like messes with your brain a little bit, but if you break your brain just right, all of a sudden it clicks and then it's magic. So there's like has, neg, maybe are kind of like the main matchers that you use when you're trying to assert that certain facts exist or they don't exist. So in this case, has store as a store. That the weirdness, which makes its way from Prolog all the way down into like all the rules engines that stem from it, is that if something has a capital letter, then it means it's a variable. And if it's a lowercase, it's a literal. And that's just something you have to accept, you know, when you're using 1970s technology. So
Good question. How would you code this in Elixir? Like, I mean, are you getting to it later on, you know? And
oh yeah, so when
Then
my
maybe.
talk ends, then James is going to step in and he's going to show like a real world working Elixir rules engine.
Awesome.
Yeah. So, but I'm not doing any live coding on my talk. James is going to.
Thank you.
So there's some matchers don't take subject predicate value. They take, you know, variable and another variable or value. So you could, they're same, different, less, greater, assign. You can define your own matchers. I'm just trying to wet your beak here a little bit. You know, yeah, this is the tip of the iceberg, right? But you could say less, burger age, 5 minutes. Now it's like, okay, I don't know, maybe I have to throw burgers out if they're too old or something like that. And then there's also matchers that set up a new condition chain, like none or any. So I could say, look, for this rule, it could be one of two cases. They have a burger in the store, or they have meat in the store and the customer is patient, right? Those are two, like in either case, let's say that this rule passes. We're going to serve them a burger. It either has to be ready to go or the customer has to be patient. Awesome. Okay. So let's go back to Slack, because again, to me, it's like this thing we all use. We know how it works, but it's full of hidden complexity, right? So we say a message is in a private channel, then the message is private. I'm trying to get at something crazy here. So a message is in a private channel, then the message is private. What's actually happening here is we're generating new knowledge. We're generating a new fact. So this is the beginning of where things start to go super crazy. The fact that a rule can generate facts is kind of part of the secret sauce here. So I could say, you have a channel and it's private and there's a message in that channel, then that message is private. The message isn't intrinsically private. Its presence in the channel that is private makes it private. So hopefully by the end of this will make sense. But like the magical properties of Rules Engine, the thing that really make it fly are inference, reactivity, and queryability. What we just saw was inference. So an action can generate new knowledge. And so message type private was generated by, a matched rule. And so rules can generate facts and they can also retract facts. And that becomes useful later too. So let's just keep going. I'm going to keep building on the magic. So let's say when there is a user and a message is in a public channel, or a message is in a private channel and the user is a member of the channel, then the message is visible to the user. Again, like this, I'm using this example because we all use Slack. I think this is how Slack must work inside. All public channels are visible. The messages in a public channel are visible to all users, but you have to be a member of a private channel in order to see a message in there. So the visibility of a message is kind of like an inferred bit of knowledge, right? But because I can infer the message is visible to the user, I can write a rule that just says when a message is visible to a user, display the message to the user. I don't have to know what makes a message visible to a user. Someone could decide that the definition of visibility changes over time. We need to make major changes to the way Slack works for some reason. But I don't have to worry about everything everywhere breaking all the time, as long as the shape of the facts and the meaning of how these things work remains consistent. So that's kind of the magic of inference. So I could later decide, if you're an admin, you have access to everything, it doesn't matter. So I write another rule. A user has the role admin and there's a message. Well, then the message is visible to the user. And this rule doesn't really care. Like as long as that fact is true via inference or direct fact or whatever, it'll work. Okay. Inference is crazy. I'm about to jump into reactivity. Does anyone have questions about inference? And I'm sorry this is so dense.
So in this case, like a rule is sort of emitting a fact.
Yes.
And the fact is evaluated against another rule to have an action or to actually do some action, right?
I think what you've done is you've jumped to my next slide in your head because you can see it coming. It's because the reactivity is the fact that as facts are added, they're immediately matched, it immediately reevaluates the patterns and sees whether there are new rules that need to be triggered, or rather actions that need to be triggered as a result of rules. So as facts are added, matching rules trigger actions. As rules are added, they'll fire for any existing facts. That's arguable depending on how you want it to work. And as facts are retracted, actions can be deactivated. So effectively, if you have a rule that generates a fact, that fact gets added and then immediately evaluated to see if there's any like consequences from that. And in theory, it can just like keep going forever. And so, not to get into it, but like the way Erlang in the early days worked was effectively something going forever was a process. It was like at the end of it, it just kept going back to the top again, and anyway, I don't want to talk about that. So the reactivity though is magic, because here's an example. Imagine there's no burgers in the store, close the store. We already talked about it, right? But what happens if I go and I, add a burger to the store? So now there's a burger in the store. I want to open the store again. Done right, well, that's automatic, because we need to undo closing of the store, because now we're retracting this. This is no longer true. So in theory, again, you don't have to use it this crazy, but if that's the way you want to go, like you can basically make it so that, let's take a shipment at store contains burger. I'm on when shipments arrive, add the contents to the store might be a rule. So I have a shipment and the shipment's at the store and the shipment contains items or a item, and then generate item in store. And so a shipment comes in, it gets unpacked, the contents are added, and that undoes the closing of the store. And so this is like inference on top of reactivity, creating this like magic situation where you don't even, there's all this emergent behavior, I guess you would call it. Okay. And then queryability is effectively, if you don't care about actions, you can also just have a series of conditions and just show me all the combinations of facts for which this pattern would be true. So you could think of it as like a SQL query or something like that, but it's very like query by example, many to many, magic-y. Okay, so complex logic. This is kind of this is a huge chunk of this crazy Slack flowchart as rules. So, I mean, it's not all of it because I can only fit so much on one screen, but this is entirely like everything that covers the notification preference, everything. And this is like multiple devices for a given user. As long as all of that's loaded in, like this would, send a notification to the device. If it's not muted and their notification preference is everything, and then it like either the global device preference or they have a specific device preference for that channel saying notify me, all that's done. So like I'd say this is half of this diagram already covered by this. So there's your kind of complex logic. So you know what, I'm almost done, guys, and then I'll hand it over to James. But real quick, why did Erlang or Elixir move off of Prolog? This, I think I've more or less covered like what the magic is. It's also, you probably saw a little bit of how it breaks your brain maybe. So there's like, that's maybe why you don't want to use it. But why did Erlang or Elixir move off of Prolog? This is the relative speed of C, Perl, Ruby, and Prolog. And so it's like Prolog is horrifically slow. Like to the point where on your modern computer, if you try a trivial Prolog program, you will be able to watch it operate. So yeah, it's like pretty bad. So and so from use of Prolog for developing a new programming language, Joe says that after 3 years, program design using Erlang required between 7 and 22 times less work. And so satisfied with the expressive power of their language, their users required an implementation was at least 40 times faster. And so they were forced to bail on it. And the timelines are such that any of the things that were happening around speeding up rules engines weren't really in place at the time that Erlang was being developed. And so because they didn't have, well, basically they lost the requirement of volatile requirements. And so their speed became their concern, and that's, was a problem. So to kind of like end here, this is a quote from Joe: make it work, then make it beautiful. Then if you really, really have to, make it fast. 90% of the time, if you make it beautiful, it'll already be fast. So really just make it beautiful. So I think rules engines are beautiful. They definitely weren't fast enough. And I think that this is Joe kind of speaking to that, right? And I think that I can only imagine that he might have wished that he could have kept some of the magic of the rules engine. in there. And I don't know, maybe James will make it so that we can keep the. So anyway, that is it for me. Thank you, everyone. That's all I got.
Thanks, Luke.